Hi, Algebra 2 students. This video is going to first kind of explain to you how you're going to finish creating your unit circle, and then I'm also going to do some examples to help you in class for Wednesday. In the event of snow, I still want you to watch this video and take these notes, and we'll just kind of pick up with the practice aspect of that in class on Thursday. Okay, so if you recall where we had left off, so if you're in my 6th period, I think you got a little bit further than this, but this is from my, or maybe this is 6th period and my 4th period got further than this, but I'm going to kind of back up a little bit. So what we had done in class was we had drawn in the y-axis, the x-axis, 0 degrees, 90 degrees, 180, 270. We labeled those coordinates 1, 0, 0, 1, negative 1, 0, 0, negative 1. And then we started to come in with our special right triangle. So we did the 30-degree angle, and we knew that the coordinates were going to be the x value is root 3 over 2, the y value is 1/2, so we wrote that in. I'm going to add to this now and say we're going to draw a line that connects from the center to that 30 degrees, and I'm going to use yellow to kind of match the color here. If you do not have colored markers or pens or colored pencils, you could just kind of draw this in one color, and in class, when you get to class on Thursday or Wednesday, you could go over it any color. Okay, but I'm trying to make this as visual as possible, so that one is yellow. And then I could do the 45-degree angle, this one, and I hadn't even gotten to writing the coordinates, but the coordinates for this one are going to be root 2 over 2 and root 2 over 2, right? I'm going to start writing on the outside, actually. And I am going to now connect the dots in pink this time because I'm using my pink triangle. Okay, and then the last one is going to be the 60-degree right triangle. So notice it is labeled with the short leg as 1/2, the long leg as root 3 over 2. It enables us to kind of get that spot on the unit circle, on the edge of the circle, and we're going to call that 60 degrees. And then I need to write the coordinates. So again, if you think about what's going on here, the x value, you're going over by 1/2 and up by root 3 over 2. And now I'm going to draw in the line connecting in purple because of the purple triangle. All right, so we've now completed 1/4 of the unit circle. But what we're going to see is that we can place these special right triangles in their position in every single quadrant, right? So there's going to be another yellow one, right? It's going to come up over here. And now its reference angle is 30 degrees, but that's not a 30 degrees around the circle from here, right? So if you think about visually, you start rotating like this, how far around the circle is it once we get here? Well, because we know that's 30, we know this is just 30 degrees less than 180. So if I do 180 minus 30, I'm going to get to 150 right here. Okay, and then the idea would be, okay, now what are the coordinates? Or let me draw on the yellow line first, and then we'll talk about the coordinates. Okay, so I'm going to draw in that yellow line. And then if I think about the coordinates, now I know I'm going over by a distance of root 3 over 2 and up by a distance of 1/2. But I'm going a negative distance along the x-axis. So that means root 3 over 2 has to be negative when I go to write the coordinates. But since I still went up in the positive direction on the y-axis, I have positive 1/2 there. So notice the x value is negative, the y value is positive there, okay? And we're gonna kind of repeat this process a couple of times for these other triangles as well. So we're gonna kind of get the same 3 lines in all of your quadrants, okay? So I would like you guys to pause the video to try to work your way through this. And then in a moment, I'm gonna pause my video and then I'm gonna show you what the completed unit circle should look like. All right, guys, so what you should have is going to be a completed unit circle that looks something like this. Now notice I kind of switched out my old version. This was kind of like my halfway completed version, and now I've revealed to you guys a brand new completed unit circle, and you should kind of compare and make sure all of your values match up to mine and you have the right signs. So one thing to kind of notice in terms of patterns is like any lines we drew in yellow, notice have the same coordinates, like values, they just have different signs. So here both are positive. Here the x is negative, the y is positive. Down here the x and y are positive, and down here only in the fourth quadrant only the y value is positive or negative. My bad. Okay, so the idea is you want to check this unit circle, and now moving forward we're going to be able to use this and sort of memorize these patterns to allow us to then get the sine or cosine values of angles more easily. Okay, so at this point in time, what you should do is take out your notebooks, and the next part of your notes are going to go directly into your notebooks, and we're going to call these notes trig and the unit circle. So title your notes, trig, and the unit circle. So the first thing we're going to do in these notes is just quickly define what the unit circle is and draw a quick sketch. I'm not going to do as much as we just did. I meant to write the unit circle. So we say the unit circle is the circle centered at the origin with a radius of 1. Okay, so I'm going to draw a quick picture. I'm going to use my graph paper to my advantage to try to help me draw a more precise circle. We'll see how it goes. Okay, not too bad. So remember, we have this unit circle. We can label those 4 main points. We know this is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And then we also know what the angle measures are that correspond to those places, right? So this is 0 degrees. It's also 360 degrees. We have 90 up here, 180, and 270. And then we always think about the fact that we can draw some angle. I'm calling that angle theta. I'll zoom in a little so you can see that better. And then for any angle theta that comes from this positive x-axis and kind of gets rotated up, we can draw a right triangle by dropping it down. The only only angle measures we can't draw a right triangle for are if you're at one of these 4 coordinates along the x or y axis. But we already know what the sine and cosine values are there, so we're good. And then there's this point at which the angle crosses the unit circle, and we're going to call that point x comma y, right? Well, what we have figured out is that that point x and y are exactly cosine of theta comma sine of theta. So this will always be the x and the y coordinate of that point on the unit circle. All right, so now that we kind of understand the relationship between the unit circle and sine and cosine, in that they are exactly the x and y coordinates along the unit circle. We want to kind of remember that we have other trig functions, right? So one of the other trig functions we have is tangent. So let's remember tangent. Tangent is opposite over adjacent, right? So if you use the unit circle and you think, what is the opposite side? It's the vertical side, so that's y, over adjacent. The adjacent side is exactly the x value. So then I should get tangent is exactly y over x. Okay? But we just stated that y is sine and x is cosine. So what does that mean? It means that tangent is exactly the same as doing sine theta divided by cosine of theta. And this becomes a very, very useful relationship to remember. Tangent is sine over cosine, because if I have an ordered pair, I can do the y value of that ordered pair divided by the x value, and I will always know my tangent value. Okay? I'm going to kind of put this in a little cloud so we know that's important. And then I want to just remind you of those other trig functions that were new this year. So the other new functions were secant theta, which we defined to be 1 over cosine. And so the idea would be, if you know the cosine value from the x value here, we would do 1 over that to get the secant value. Okay? And then we had CSE, cosecant, which is 1 over sine theta. And then we also had cotangent, which is 1 over tangent. But now something to think about here is when I say 1 over, that's the same thing as saying the reciprocal. Okay, so this is important because with tangent, well, this allows me to then get cotangent in terms of sine and cosine, because tangent is exactly sine over cosine. So cotangent should be the reciprocal of that. So instead of sine over cosine, I'm going to write cosine theta over sine theta. Okay? And now you have all of the other trig functions in terms of sine and cosine. So that means if you know the ordered pair x comma y on the unit circle, you should be able to find all the other trig values. So let's see how this works in some examples. Okay, the first example we're going to take a look at is going to be where theta equals 120 degrees. So you should, like, to start, you can have your unit circle kind of handy, and you can kind of see, where's 120 degrees? Oh, I now see what the coordinates are there, right? But eventually, you're going to need to memorize these relationships. So I'm going to sort of model for you guys right now a process by which you could kind of figure out what 120 degrees needs to be in terms of sine and cosine by just kind of intuitively thinking about the unit circle. So the idea here would be that it would be helpful if I say, so if theta equals 120, and then I say I want to find cosine of 120. I want to know what that equals. Well, I'm going to first draw a picture. So I would like to know, where does 120 degrees fall on the coordinate plane? Well, here's 0, here's 90, here's 180, so, and 270. I know 120 is somewhere between 90 and 180. And it's closer to 90. It's only 30 degrees more than 90, right? So I can kind of imagine like the halfway mark, and then I need to go a little bit closer to 90 degrees. So we get something like that, okay? So that is telling us that this is 120 degrees. But remember, every single place on the unit circle corresponds to one of those special right triangles. 120 degrees, notice, is purple. That means it's going to correspond to a 60-degree angle. But it also makes sense because if you think about it visually, right? If we make this a right triangle, then I can say, what's this angle right here? That angle right there is going to be however much more it takes me to get from 120 to 180. Well, 180 minus 120 is exactly 60 degrees. So I know I'm working with the 60-degree angle right here. And then I also think very visually about this, and I see that my short leg is on the bottom, is my x value. My long leg is going up, is the y value. So what that means, I know that for a 30, 60, 90 triangle, the short leg is always 1/2, the long leg is root 3 over 2. So this is cluing me in to know that this must be the coordinates here, must be, the x value has to be the short side, 1/2. The y value would be root 3 over 2. And then I also want to consider if either of those values needs to be negative. And since I'm going on the negative x-axis, I'm going to put a negative sign in front of the 1/2. So now that I know cosine comma sine, then cosine of 120 is exactly the x value, negative 1/2. Okay, well, what if I then asked you for secant of 120? Well, we said earlier, let's scoot up a little bit, secant is the same thing as 1 over cosine, right? Or you could think of it as, right, the reciprocal. So I could flip negative 1 over 2, and that would give me negative, it doesn't really matter where the negative is, if it stays with the 1 or if it goes down with the 2, but we get negative 2 over 1, which is just negative 2 for secant. Okay? So we just kind of were able to sort of like build the little picture we needed that enabled us to identify which special right triangle are we using, remember this is called a reference angle, and then that allowed us to then find different trig values. So let's do another example. Okay, so for the next example, we're going to use the angle of negative 150 degrees. Okay, and I'm going to ask you, we're going to try to find tangent of negative 150 degrees. Okay, so the idea here is I'm still going to draw my picture, but we have to remember that a negative angle is rotating the opposite direction. It's rotating clockwise from here, so it's rotating down. So I'm going to kind of label my degrees a little bit different. I'm going to call this negative 90 and this negative 180 right now, because that's going to help me place negative 150 somewhere between negative 90, negative 180, and it should be closer to 180, right? So there's the halfway point, so I'm going to put it a little bit closer in, something like that, okay? And then the idea would be, well, if this is negative 150 degrees, what is this other angle in here? Well, it's what's left to get to 180, so that must be 30, right? So now I know that this triangle is the 30, 60, 90 triangle, where this side, the short leg, is the y value, the long leg is the x value. So the long leg is root 3 over 2, the short leg is 1/2. And then I have to think about which ones should be negative, which ones should be positive. Well, I did negative x, negative y. And so they both need to be negative at that point, okay? Now coming over to tangent, I know tangent is sine over cosine. So sine is y, negative 1/2, over cosine, which is the x value, negative root 3 over 2. So now this doesn't look so nice. We have like a fraction over a fraction, but I want to remind you that dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to do negative 1/2 times the reciprocal here, which would be 2 over negative root 3. From here, notice the 2's actually cancel. And so if you remember that those 2's are going to cancel, you could kind of identify it earlier. And so if you see that both fractions have the same denominator, you could kind of cancel those out. What do we get then? We get 1 divided by, now notice because they were both negative, negative times negative or negative divided by negative will turn positive. So then I have 1 over the square root of 3. But I don't want to leave that square root of 3 in the denominator. So I'm going to multiply top and bottom by root 3. And I end up with root 3 over 3. Okay, so now I know that tangent of negative 150 is equal to root 3 over 3. One more value here, let's do cotangent of negative 150. So I know that's the reciprocal of this, 1 over this. So I could flip this, but then I have my root back on the bottom. So better to go back to the one right here. We had 1 over root 3 and flip that one. But then we end with a radical on top and I won't have to rationalize again. So I'm going to flip this and I'm going to get the value of root 3. Okay? So on the classwork, if you do have class on Wednesday, some of the questions are going to ask you for trig function values where instead of degrees you have radians. So if you're given radians, I'm going to recommend that you convert it to degrees first. So the way we do that is say you have like 5 pi over 4. Then you would multiply that by 180 over pi. And the answer would tell you your degree equivalent, okay? So if you have class with the sub on Wednesday, do the best that you can on the classwork. I'm going to say you don't have to do any homework. We'll go over any questions you have in class on Thursday. Have a great evening.